Hello students, it's Mr. Nguyen here. Today I am showing you our lesson 9.3, Geometry, Properties of Rectangles, Squares, and Rhombuses. This lesson comes with two IXL practices that are listed here. You can stop at around 50 or 60 for each of the practices, okay? So, how does understanding polygons help us shape the world around us? Well, today, one of those polygons will be these special parallelograms that we have talked about. And today, we're going to take a look at closer look at their properties and how to use their properties to solve problems involving squares, rectangles, and rhombuses. Okay. So let's first talk about the squares. The square is the uh, most special parallelograms, okay, because the square has four equal sides and four right angles, okay, and it looks like this. So if you look at the square, there's a lot of stuff going on here, okay? But the first, we're going to go with definition. The four equal sides and four right angles, okay? So each angle measures 90 degrees, okay? Each vertex right here, 90 degree, and each of the side is equal. Besides that, it has some other properties as well, okay? So the diagonals cut each other in half, and they are actually equal to each other. So each piece of the diagonals are congruent to each other. And as you can see in the picture here, the diagonals also create a 90-degree angle right in the center, which means all of these four little triangles are all right triangles. And as a matter of fact, they are all equal to each other, okay? Um, so if you can refer to this picture when you are doing your practice, it will be very helpful, okay? So non-example of a square, a trapezoid is not a square. It doesn't even belong to the parallelogram group, okay? Next, we'll talk about the rectangle. The rectangle is special. It's not as special as the square because it only has four right angles. That means the sides are not necessarily equal to each other. As a matter of fact, the rectangle does not have equal sides, okay? It does have opposite sides that are equal because it is a parallelogram, okay? So here's what the rectangle looks like. Now, it does have some properties that the square has. For example, the pieces of the diagonals are equal. However, the triangles are not equal. Only the opposite triangles are equal, right? The vertical ones are equal because not all the sides are equal. The angles are 90 degree in here, but the angle in the center is not 90 degree because these do not uh, intersect each other at a perpendicular line, okay? So refer to this picture when you are working with the rectangles, okay? And study these properties right here. It will come in very handy because they're gonna help you set up the equations when you are solving problems, okay? Again, a trapezoid does not belong to the rectangle. Last, we'll talk about the rhombus. The rhombus is like the rectangle. It has some properties of the squares, okay? It shares half of the properties of the squares as the rectangles. So it has four equal sides. And now notice it doesn't have four right angles, right? Just four equal sides. However, the center angle is actually a right angle, okay? Which means this is a right triangle, 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 okay? And again, this right triangle is equal to this right triangle, and so this one is equal to this one. The diagonals bisect each other. However, the pieces are not equal to each other. Um, the diagonals also bisect the angles here. That means it cuts this angle in half, as this half equals to this half. That information is very important to notice when you are working with these rhombus problems, okay? Again, here you can see this angle right here is being bisected by this diagonal, so it's half and half right here, right? Okay, so refer to this picture when you are working with rhombuses, okay? And study these diagonals. I mean, these properties. I'm looking at diagonals. So notice property 6 diagonals are not congruent, okay? Again, a trapezoid does not belong to the parallelogram group. All right, so we talked about many types of quadrilaterals. Last time we talked about the parallelogram, okay, the special quadrilateral. Today we talked about this group right here, the rhombus, the rectangles, and the square, which are parallelograms. They are just more special, okay? Let's take a look at this first example, okay? So you are given the pieces of the diagonal. You giving VS is 76 and SU or US is 87. And you got these markings here where this half is equal to this half and this half is equal to this half, and it's asking you, is that enough to say that it is a rectangle? So let's check the properties real quick. So this looks like it bisects, but the definition for a rectangle, remember, is four right angles. That's the very first thing that we looked at, right? It's four right angles. Diagonals are also congruent, but in this case, the diagonals are not congruent because these pieces should be equal to each other, right? So, I mean, it also, so this is not a rectangle. This is not a rectangle, okay? So you got to review your properties to disprove it. If it is the correct shape, it should meet all the properties, okay? Another question, is this a squared? Well, the diagonals bisect each other, all the pieces are equal, and that's a 90-degree angle right here. So if all of that is true, then all of these little right triangles, all of these right triangles are equal to each other. So I think that is enough for us to say that it is a square, okay? Next one, is this a rhombus? Okay, so to be a rhombus, you have to have the diagonals have to bisect the vertex. So it has to cut R in half and it has to cut T in half. But according to this picture, the two angles are actually different. One is 72 degrees and one's 73 degrees. So it is not a rhombus. Okay. Here's some problem solving. We have a rectangle STUV, and we are given RS, which is 2V, and we are given RV, which is V plus 41, and the question is asking for segment RT, which is this segment, how long it is, right? Well, we know if this is a rectangle, then we know the property is what? All the diagonals pieces are equal because the diagonals get bisected and the diagonals are also equal. So each of these little pieces are equal to each other. Well, if they are, then we can set up an equation um, that says RS is equal to RV because these pieces are equal. So we can solve this quick, easy one-step equation, and we can get an answer for V, right? V is 41. And then it's asking for RT. So, well, RT is the same as RV. So we'll just put the 41 back into RV, which is 41 plus 41, which is 82. So we know that RT has to be 82 units long, okay? Next one, we have a rhombus here, and we're given this side and this side, the two adjacent sides. Well, the one of the properties of the the definition for rhombus is that all four sides are congruent, right? So all of these are congruent, so all of them are equal. So this is the same concept essentially as the rectangle problem. We can set FG equals to FI, right? Or GF equals to IF. It doesn't matter how you say it. IF equals to FG, as long as you set these two expressions equal to each other, right? And then we can solve the equation real quick. Subtract A, and so 2A minus A is A, and then A is equal to 7. It's asking for GH. Well, GH is the same as IFI, or it's actually GH is any of these is fine. As any of them is fine, right? And so we substituted in for 2A here, and we do 2 times A, which is 2 times 7, and that's going to give us 14, okay? So GH is 14 units long. All right, here's another one. We have a squared, right? We have a squared, and all four sides of the squares are congruent, so we set them equal to each other. And we solve the equation. We subtract c, we get 10c equals 50. We divide it by 10, we get c equals to 5. And that's all this question is asking. It's asking us for c. It doesn't ask for a segment, okay? This one, we have a rhombus here, and here is why the answer is 62, okay? Let's take a look why the answer is 62. So we are looking for this angle right here, BAC, okay? And I'm going to explain to you why the answer is 62 here in a second. BAC is the unknown angle. That's what we want, okay? Now, part of the properties of the one of the properties of the rhombus is that the opposite angles are congruent, right? Diagonals also cut them in half. So if I draw a diagonal, BD is going to cut that angle up here in half, which is half of 56, because I know angle B is the same as angle D, so it's going to cut that in half. Also, the diagonals are perpendicular, which means that the center angle is 90 degrees, okay? And so I have essentially a right triangle here, right? So if I have a right triangle and the total measure of this triangle is 180, then I can just do, oh, well, I already have 90, so I do 90 minus 28 to give me this angle over here, which is 62, okay? Here's another one, okay? We're looking for GFJ, okay? We're looking for GFJ. We know that diagonals are perpendicular, so we have a 90-degree in the center. We have GFJ, we have diagonals bisect, so we have a 27-degree down here, the same as this one. And we have an expression for GFJ, which is z plus 52. So if you would add these two, 27 plus z plus 52, so if you add this little angle to this little angle, the sum should be 90 degrees because you already have 90 here. So these two angles have to be the other 90 because the whole thing is 180, right? So that's what I'm going to do to set up my equation. I add 27 to z plus 52, and I combine like terms, and then I'm going to subtract the 79, and I will get z equals to 11. Okay, it's another similar one. Okay, same thing here. I have 29, so I have 29 over here and a 90-degree in the center because this is a rhombus. And the angle that they give me is angle VUW, which is this angle right here. And so again, I have a 90 already. So these two little angles, the 29 should be the same as the other half, right? So 29 over here, 29 over here. So this 29 degrees plus s plus 40 should give me 90 degrees again. And I combine like term, I guess 69. 90 minus 69 is going to give me 21. Okay, so that's pretty much it. You guys go try these practices and let me know if you have any questions. I hope that helps. There are also additional videos if you would like to look at on YouTube. So if you go back over to the calendar that we have, it's our geometry calendar. Geometry calendar has additional videos right here on YouTube that shows you more examples. So anyway, thank you for watching, and I will see you in class next time. Bye bye.